Hello all! Today we will continue our lesson about rates of change. So this is the second topic. We will learn about how we calculate the connected rate of change. The learning objective is solving problem involving rates of change and apply the chain rule to solve problem involving connected rates of change. Before we have the example of the solution, let's review what we have last meeting. So we know that the first derivative dy dt is the rate of change of y with respect to t or the time. Later it will be known as the rate of change or only the rate. If the variable x is linearly related to the time t, x is said to change at a constant or steady rate. If the variable varies with time t, then the x dt will be the rate of change of x with respect to time, and we can calculate the change at any instant t. Now, we have the example 3. In here, we will calculate the rate of change of the area when the side is given. Here we have side of rectangle, which is x centimeter and 2x minus 4 centimeter. Then the length x centimeter at a time t is given by x equals 2 plus 3t. Show that the area A of the rectangle in terms of t will be 12t plus 18t square, and we will find the rate of change of the area at the instant when t equals 2. So let's first prove that the area is 12t plus 18t square. The first side is 2 plus 3t, and the second side is 2x minus 4. So here in terms of t, we can substitute x with this 2 plus 3t, so that the second side is 6t in terms of t. Then the area will be x times 2x minus 4, and we have 2 plus 3t multiplied with 6t, and we prove that this is equal to 12t plus 18t square. Now we will find out the rate of change of the area, so it will be the a dt. Then we have the a dt from here become 12 plus 36t. And we calculate when t equals 2, the a dt or the rate of the area will be 12 plus 36 times 2. So this is 84 centimeters square per second. Now let's see the chain rule. We have the chain rule that connecting two derivative. In here, if we have dy dt, we can calculate dy dt using a given dy dx and the given rate of the x dt. So let's apply it in example 4. Now let's see example 4. In example 4, we have a hemispherical bowl of radius 6. It's filled completely with water. The water is then transferred at a steady rate into an empty inverted right circular cone of base radius 8 cm and height 16 cm with its axis vertical. Given that all the water is transferred in 8 seconds and V centimeter cube represent the amount of water in the cone at any time t, find dV dt in terms of pi and the rate of change of the height of the water level when the height is 8 centimeter high. So the first one, we will see that the volume of water in hemispherical bowl can be calculated using 2 over 3 pi r cube. Then, since r equals 6, we will have it is equals to 144 centimeter cube. 2 over 3 will coming from half of the volume of the sphere, that is 4 over 3 pi r cube. And here, since the water is transferred at a steady rate, then it will be calculated as delta V over delta T. It's the same with that, and the change of the volume is 144 pi, and the time of delta T is 8 seconds. so that dV dt is 18 pi centimeter cube per second. Next, since we already know that dV dt is 18 pi centimeter cube per second, later we will calculate what is the h dt, the rate of change of the height, when h equals 8. Then, later we will use the chain rule so that this dV dt can be used to calculate the dh dt. So we start by finding the dV dh first. dV dh will be obtained from pi over 3r square h. This is the volume of the cone. So this cone having the radius of 8 and the h which will be 16. Then if we are using the similar triangles, then we have the ratio of r compared to h, which is 8 over 16, or can be simplified become a half. The radius is always a half of the height. Now we can make the volume in the variable of h. Let's substitute r become a half h so that we have it in the variable of h, pi over 12 h cubed. In here we will calculate dV dh. The dV dh will be pi times h squared over 4. So since we now want to calculate the dV dh when h equals 8, so we can substitute h equals 8 and we got the dV dh which is 16 pi. Now we already know dV dt and also we know that the dV dh is 16 pi. We'll use the chain rule and substitute what we have to calculate the h dt. dV dt is 18 pi and dV dh is 16 pi, so that our dh dt will be 18 pi over 16 pi, and we have it become 9 over 8 centimeter per second. So later, if you want to directly make the h dt become the h dv multiplied with dV dt, so it is chained, still the same, you can have the dh dv obtained from 1 over dV dh. So it will be the same thing. So our conclusion for the connected rate is, if you know the changes of y with respect to x, then if you also know one of the rate of the variable, for example here the x dt, you can calculate the other rate of the variable. So since it is chained, then dy dx with the x dt can be used to calculate dy dt. So that's all for today. Let's see another example in the next meeting. Hope you can do it. See you all and bye-bye.